So last class, we started introducing some components of the Python language. And this class will continue introducing some components of Python language. And then next week, we'll sort of move on with some kind of data science. We'll talk about plotting data. We'll talk about input and output of data. So that's the sort of near-term plan. Last class, we talked about in Python variables, assignments to variables, we talked about arithmetic, we talked about functions and libraries. Our examples were that Galileo's free fall law, and doing some calculations related to that. And in the homework, it was derived from Newton's universal law of gravity, the relationship between the altitude and the period of the satellite. Today's class, I want to talk about what we call control statements in Python. So I'm going to talk about if statements and while statements, a little bit about for statements and the break statement. So those affect the kind of control of the flow through a program or through a code. The applications today be a little bit different. We've just got a couple of kind of mathematical applications. We're going to talk a bit about and calculate sequences of prime numbers. And we're going to talk a little bit about, and you'll calculate the homework, these Fibonacci numbers. So those are the two examples for today. And so I got a couple of slides. They're a little bit kindergartenish. One for prime numbers and one for the Fibonacci numbers. But that kind of lead us into the programming we're going to do. So on these slides, I'm just pointing out probably some obvious things to you about these sequences of numbers that will be relevant to the computations that we're going to do in terms of calculating these numbers. So as you know, right, prime numbers are there's prime numbers and there's composite numbers. There's prime in terms of the natural integers. There's prime numbers and composite numbers, and prime numbers are only divisible by themselves in one, and composite numbers are divisible by smaller prime numbers. And so prime numbers are kind of the building blocks of the natural numbers, is one way of thinking of, like the elements or the atoms of the natural numbers. So they're important in that sense. There's a famous proof that that's thousands of years old now, that there's an infinite number of prime numbers, and that proof, I try to write it out compactly here, but it goes along the lines of supposing there wasn't an infinite number of prime numbers. Supposing there was just finite n number of prime numbers. Then if you multiplied them all together, so prime number 1 and prime number 2, prime number 3 up to prime number n, and you added 1 to that, you can't divide that by any of the prime numbers, any of the n prime numbers. So it can't be that there is a finite number of prime numbers. There has to be an infinite number of prime numbers. So that's sort of the famous proof. What's interesting about the prime numbers is kind of the sequence of prime numbers, or the pattern of prime numbers, or things like the size of the gaps between consecutive prime numbers is unpredictable. It's what you might call pseudo-random. And so that's a very interesting feature of prime numbers. It means that you can't calculate the prime numbers with an equation. You can't calculate them with a formula. Rather, you have to search for the prime numbers, and you kind of search for the prime numbers with kind of a number sieve to to find them, to locate them. And so we'll be doing a little bit of that today as an example, using our control statements, using the statements that affect the flow of a computer program. You probably know that this kind of pseudo randomness is actually a key to methods for encrypting data. So that, and a key way of encrypting data is the fact that it's very easy to multiply two prime numbers, think of large prime numbers. Very easy to multiply them to make another number, but it's very, very hard, time consuming that is, to find the factors of that very, very large number you just made. And encryption's based, a lot of encryption is based on that. So prime numbers are important and interesting, and they offer some nice examples as we sort of learn about flow and control in a computer code. The other numbers I wanted to mention, and this is related to the homework problem, is this sequence of numbers, this Fibonacci sequence of numbers. So in this case, the numbers are predictable with an equation. So there is this equation, a simple equation for the numbers. It's what's called a recursion relation for the numbers. So you'll find the numbers from a pair of starting numbers, and you can work your way through the Fibonacci sequence or series of numbers. So again, it's just like finding prime numbers, we said you have to do that with kind of a sieve. So it was a computational technique. Finding the Fibonacci numbers is also a computational thing, because you find the numbers by starting with the beginning numbers and working your way to larger and larger numbers. So again, it's a computational thing. So that's why we're picking it. These numbers come up in nature. They come up in biology. So the most famous examples are, if you ever look at a pine cone, or get yourself a pineapple from Kroger's, then the pattern of the kind of blades on the pine cone or the pineapple, I don't know what those things are really called, but anyway, they sort of spiral around the pineapple, or spiral around the pine cone. If you look at it, here's a pine cone. And the number of these spirals are always on Fibonacci numbers. So in this case, this is A. But you can see other ones of these. You'll see 13 is another Fibonacci number. So you get pine cones with 13. And so they appear in nature. But they also are useful in computer science and computer programming for solving sort of computer problems. So one of the famous examples, I think, is if you have, sometimes a computer problem is to find a particular element in a big list, a sort of ordered list of elements. And one way of doing that is sort of kind of to divide and conquer. So if you're looking for an element in a big long list, what you might do in divide and conquer was sort of divide the list in two, and then look in one half, find if it's there. If it's there, you don't need to look in the other half. And then keep doing that, repeatedly do that, divide by your list into halves and quarters and so forth to find the location of this item. There's actually a more efficient way where you divide it according to Fibonacci numbers. So you don't divide it into halves each time. You divide it into portions that are two Fibonacci numbers. And so that's a sort of computational technique that's used to most rapidly sort of search for an item in a list. So that's a computational application of it. Anyway, here's the rule for the Fibonacci numbers. So you have two starting values. So is F0, 0, and F1 is 1. And then you calculate the following one by just adding together the previous two. So F2 would be 1. And then F3 would be 1 plus 1, so it'd be 2. And then F4 would be 1 plus 2, so it'd be 3. I might be starting to get numbers. Anyway, it's up here. So yeah, 3 is 1 plus 2, 5 is 2 plus 3, and so on. So that's a simple rule. It's not like the prime numbers, but it's not just like one formula. It's a recursion relationship. So you have to work your way along the road of Fibonacci numbers.